Hello everyone, and today we are going to discuss about our second chapter, which is polynomials. And this is about for the first introductory part, and we will get into the questions also. So to start with polynomials, what do polynomials have? How will this polynomials looks like? Do they have variables? Do they have mathematical operations? And do these variables they have power? And also, do we have constants and coefficients? So a polynomial essentially contains almost all of this, and we have different types of polynomials. So it's basically an algebraic expressions with a which involves these mathematical operations and with the powers, constants, coefficients, etc. So we are going to see the different types of polynomials. So based on the degree of a polynomial, based on the degree of a polynomial, we have three types of polynomials. So we have linear polynomial, then we have quadratic polynomial, and we have cubic polynomial. So of course, for a linear polynomial, the power of this polynomial will be 1. For example, a polynomial of degree 1. Okay, of a polynomial of degree 1. So what we call degree of a polynomial, the highest power in a polynomial, we call it a degree of a polynomial. So if it is a linear polynomial, the examples are 2x minus 3 is an example for a linear polynomial, and also 3z plus 4, and also 4t plus 1, or we can say 2 by 3 u plus 1. Okay, here the only condition is that the power of this variable should be 1. Okay, the power of the variable should be 1. Such polynomials we call them linear polynomial. Now, next is quadratic polynomial. So, for quadratic polynomials, here the degree of the polynomial will be 2. The degree of the polynomial will be 2. So, if the degree of the polynomial is 2, what can be an example of a quadratic polynomial? So, the examples for a quadratic polynomial, or what we call a quadratic polynomial, a polynomial of a degree 2, we call it a quadratic polynomial. Now, the word quadrate, it means square. Okay, the word quadrate, it means square. So a quadratic polynomial is of degree 2. Now the examples are the same. We can write like 2x square minus x minus 3, or we can write minus 2u square plus u by 3 plus 5. Here we have u to the power 1 and also u to the power 2. So here the highest power of u is 2. So this is a quadratic polynomial. Or we can write y square minus 2. This is also a quadratic polynomial. Or we can write 2 minus x square plus root 3x. So this is also a quadratic polynomial. Now, next is a cubic polynomial. So for a cubic polynomial, here the degree of the polynomial should be 3. The degree of the polynomial will be 3. The degree will be 3. Now, for a cubic polynomial, the examples can be x cube plus 3, or we can write like x cube plus 2x square plus 3x, or we can write z cube minus 3z plus 9. So, or we can simply write root x cube or 2 minus x cube. These are all examples of cubic polynomial. So, for a cubic polynomial, the definition is a polynomial of degree 3. Now, here, what is the general form of a linear polynomial? It is always ax plus b, right? We have a as a coefficient of x, then we have x as the variable, and then we have b as the constant. So this is the general form of a linear polynomial. Now for a quadratic polynomial, what is the general form? For a quadratic polynomial, the general form is ax square plus bx plus c is equal to 0, where a is the coefficient of x square and b is the coefficient of x and c is a constant term. Now here for a cubic polynomial, the general form of a cubic polynomial is ax cube plus bx square plus cx plus d is equal to 0. So this is the general form of a cubic polynomial. Here a, b, c are real numbers. A, B, C and D are real numbers. Now here A is the coefficient of x cube, B is the coefficient of x square and C is the coefficient of x and D is our constant term. So this is our general form and these are the examples. So I hope these three types of polynomials is clear for you. Now coming to the topic, that is polynomials, how we are going to define a polynomial? If we have a polynomial, if p of x is a polynomial in x, how are we going to say it's a polynomial? Okay, or how are we going to say the 0 of this polynomial? Okay, suppose there is a value k. So when we put k in the place of x, if we are getting 0, we can say that k is the 0 of this particular polynomial. So for a real number k is said to be a 0 of the polynomial p of x if p of k is equal to 0. Okay, for example, if p of x is equal to x square minus 3x minus 4, if we are putting x equal to minus 1, what we are getting? Minus 1 the whole square minus 3 into minus 1 minus 4. Now minus 1 the whole square, it's 1 itself. Now minus 3 into minus 1, it's plus 3 minus 4. So 1 plus 3, 4, 4 minus 4, we are getting 0. So if we are getting this value as 0, then that means minus 1 is a 0 of this particular polynomial. Minus 1 is a 0 of this particular polynomial p of x. So that is the meaning. So I hope this is clear. Now, here an example, a graph is given and here it is a linear equation. It is for a linear equation. So here we have a graph of y equal to 2x plus 3. So when we take y equal to 2x plus 3, we are getting a straight line. So how we are going to jot down the values for marking the graph? So when we have y equal to 2x plus 3, what we are going to do? We are going to draw this box of x and y. Okay. Now, if we are putting x as 1, what we are getting the value of y? 2 into 1 plus 3. So it's 5. Now, if you are putting the value of x as minus 1, what we are getting the value of y? Minus 2 plus 3. So it's 1. And if we are putting the value of x as 0, what we are getting the value of y? We are getting it as 3. So we are getting some points. Now we are going to mark it on the graph. So when we mark it on the graph, we will, so suppose this is a graph. So we have, in y we have up to 5. So 1, 2, 3, 4, 5. So 1, 2. Now this is our y, and this is our y dash, and this is our x, and this is our x dash. Now this is our 0. Now 1, 2, 3, 4, 5. Here also -1, -2, -3, and -1, -2, and -3. So this is our graph. Now we have to plot these points. The first point is 1, 5. So 1 on the x-axis and 5 on the y-axis. So the point will come here, 1, 5. Now the next is -1, 1. -1 on the x-axis and 1 on the y-axis. So it will come here, -1, 1. Next is 0, 3. 0 on the x-axis and 3 on the y-axis. So this will come here, 0, 3. Now what we have to do is we have to draw this point, a straight line through these points, and see where it touches the x-axis. So this particular line touches the x-axis at -3/2, 0. That means the x value here is -1.5 or -3/2. So this is the value of x for this given polynomial, 2x minus 2, y equal to 2x plus 3. The value of x is -3/2. So this is the 0 of this polynomial. Okay. So this is the 0 of the polynomial. So wherever the graph touches the x-axis, that is our solution. Wherever the graph touches the x-axis, that is our solution. So here you can see here, the graph touches the x-axis exactly at -3/2, 0. So that is our solution. Okay. So wherever the graph touches the x-axis, that is our solution. Now let's move to the next one. Here, x square minus 3x minus 4. It's a quadratic polynomial. Okay. Now you have to observe this here. When you did a linear polynomial, you got a straight line as the graph. Now next we are going to try for the quadratic polynomial. So for a quadratic polynomial, let's see how the graph will looks like. So it's x square minus 3x minus 4. So what you can do is you can write y is equal to x square minus 3x minus 4. In the same way, we are jotting down values for x and y. So you can draw a box like this and try to find out points. So when we put x equal to -2, we are getting y as 6. And when we put x equal to -1, we are getting y as 0. And next, when we are putting x equal to 0, we are getting -4. When we put x equal to 1, and then we are getting y is equal to -6. So like this, we will get points. Now, if we are plotting this on the graph, we will get a parabola like this. We will get a parabola like this. So this shape, we call it a parabola. Okay, it will not be a straight line. It will be a curve. Okay, it will be a curve. We call this a parabola. So for a quadratic polynomial, the graph will always be a parabola. And here also, if you see this picture, the graph touches the x-axis at 2 points. So here, the value of x can either be -1 or 4. So -1, 4 are the solutions for the given equation. So for the given equation, y equal to x square minus 3x minus 4, there are two solutions possible. Here, two solutions or two zeros of the polynomials are possible. And also observe that the graph touches the x-axis at exactly 2 points. Now, let's try some of the graphs and let's see how many zeros they have. So this is our first one. So here the graph touches the x-axis at 2 points, one at A and one at A dash. So this particular graph will have two zeros of the polynomial, right? They will have two zeros of the polynomial. Now, what about this one? Here also the graph touches the x-axis at 2 points. So we have again two zeros of the polynomial. Now, what about this one? Here the graph touches the x-axis at exactly at 1 point. Okay, so we will only have one zero of the polynomial. Here also the graph touches the x-axis exactly at A. So here also we have only one zeros of the polynomial. It may touch the y-axis, but it doesn't matter. We only look for x-axis. If it touches the x-axis, then we have a zero of the polynomial. If it doesn't touches the x-axis, it doesn't have a zero of the polynomial. Okay. Now here it doesn't touch the x-axis, so there are zero zeros of the polynomial or zero solutions. Here also zero solutions. Okay, so I hope this part is clear. For a linear polynomial, we have the graph as straight line. Our graph will be a straight line, and for a quadratic polynomial, our graph will be a parabola. Our graph will be a parabola, and wherever the x-axis touches, wherever the graph touches the x-axis, that is our solution. And also, for a linear polynomial, we will have at most one solution. And for a quadratic polynomial, we will have at most two solutions for a given quadratic polynomial. Okay, for a given quadratic polynomial, we will have at most two solutions. Now that's about the linear polynomial and the quadratic polynomial. Now about cubic polynomial, in the same way, when we jot down the points and draw the graph, we will get a shape like this. So here you can see that the graph touches the x-axis at 1, 2, 3. So we have three solutions here. We have three solutions here. So a cubic polynomial can have at most three solutions. Okay, at most three solutions are possible for a cubic polynomial. For a cubic polynomial, at most three solutions are possible. Okay. Now, what do you think about the first graph? How many solutions are there? Now, how many solutions are there? Here, obviously, here there is only one solution, but here we have two solutions. So a cubic polynomial can have this one solution or two solutions, or it can have three solutions. So there are three cases for in the case of a cubic polynomial, we can have either one solution or two solution or three solution. So we can say in general at most three solutions are possible in a cubic polynomial.